We are going to start today the lecture 3 of chapter 10 class 9th mathematics circles. In this lecture we will talk about the results related to the angle subtended by the arcs of the circle. So what our first result is saying is that if a circle is given to us and the angle subtended by the arc at the center we are talking about. So this is the circle that is given to us. We are talking about this arc AB, the angle subtended at the center by this arc. It is this angle at O. And angle subtended at any point, other point on the circle at this point C. This is the angle subtended at the C. So what the theorem says is, if this angle is X, then this angle is 2X. This thing we have to prove. So we are having three cases over here. The first is that the arc AB is the minor arc. Second is the arc AB is the semicircle. So in case of semicircle, we are saying this AOB. It is the diameter. We are talking about this arc over here. So the arc subtends this angle as 180 over here, and the angle subtended on the circle. This angle subtended on the circle, we have to prove that this angle is half this angle. That is, this angle is 90 degrees. And in the third case we are talking about the major arc. This is the major arc. This is the angle subtended by the major arc, and we have to prove that the angle subtended at any point on the circle is half that of the angle subtended at the center. So how we are going to prove this is, in the first case we are going to do the construction over here, and the construction is that we have joined the points A, B, and we have joined the points C, O. Then we have extended this CO in this way to the point D. Now we are having two triangles over here. One is this triangle we are talking about, AOC, and second triangle we are talking about is COB. These are the two triangles we are talking about. If suppose we mark these angles in this triangle as, for this angle we are saying this is X, this angle is Y, and this angle is Z. Similarly, we are writing this angle is A, this angle is B, this angle is C. Now, if we look at these triangles over here, what we see is that this OA is the radius of the circle, and this OC is the radius of the circle. So if we look at this triangle over here, OAC, what we get is these two sides, these are equal. It means these two angles, angle at A and angle at C, these two angles, these are equal. Suppose they are equal to X. Similarly, these two angles, these are equal. Suppose they are equal to A. Now look at this triangle over here. I am drawing this triangle again like this. We are having, this is A, this is C, this is O, and this point is D. I am talking about ACO triangle and this OD over here. Now what we have over here is, we are saying these two angles, these are X, and value of this angle is Z, and we know that the exterior angle of the triangle is equal to sum of interior opposite angles. So we get Z is equal to X plus X, that is Z is equal to 2X. Similarly, if you look at this triangle over here, COB, for this OD is we have extended in this direction. So what we have over here, this B is the exterior angle, so we have B is equal to A plus A, so B is equal to 2 times A. So what we have in this triangle is, this angle we are saying this angle is X, this angle we are saying it is A, this angle is Z, this angle we are saying it is B. So this total angle is Z plus B, and this total angle is X plus A. And if we add these two equations, I am talking about these two equations, this is B is equal to 2A and Z is equal to 2X. So what we get is B plus Z is equal to 2 times X plus A. So what we have proved is B plus Z is this angle, that is angle subtended by the arc at the center, and x plus a is the angle subtended by the arc at any point on the circle, and this is what we have to prove, that this angle is, the angle subtended at the center is double the angle subtended at any point on the circle. The similar proof, this works for this second case over here. The similar proof works for the second case over here, and what we get is that if this angle is 180 degrees, then this angle is 90 degree. So we can also say that if we are having any semicircle, then any angle over here, this will be of 90 degrees. You can also say the theorem in this form. And in the third case, we can prove that for the major arc AB, the similar result holds, because for the minor arc the result holds. Then we will subtract, to prove these results, we will subtract the angles from 360 degree, because if the measure of this angle is x, then the measure of this angle will be 360 minus x, and we will be able to prove the result for this third case also. Now the next result that we have is the angle in a semicircle is right angle. So this thing we have already proved in our second part. So we are saying any semicircle is basically given to us. This is the semicircle that is given to us, and the angle subtended in the semicircle means we are talking about this angle AC over here, and we have to prove that this angle is 180, is right angle. So what we have is this AOB. If this is a semicircle, this is AOB is the diameter. If AOB is the diameter, then this angle is 180 degree. Then from our previous result, we know that the angle at any point on the circle will be half of this. So it is 180 by 2, that is equal to 90 degrees. And this is what we have to prove, the angle in a semicircle is right angle. This is the result, the angle in a semicircle is a right angle. Now the next result we have is the arc of the circle subtended a right angle at any point of the circle in its alternate segment is a semicircle. So this is just like the converse of the previous theorem. So in this we are given this angle is 90 degrees, and we have to prove that this arc that is subtended over here, this ACB we are talking about, we have to prove this is a semicircle. So to prove this, we are saying that we have joined these points A, O and O, B. So basically we have to prove that this angle is 180 degree, and if this angle that is given to us is 90 degrees, then this angle should be double of this. So it is 2 times 90 degree, that is equal to 180 degree. And if this angle is 180 degree, it means this is a, this line AOB is a straight line. This line AOB is a straight line, and if this is a straight line and it is passing through the center O, it means this is the diameter. So this proves that this ACB is a semicircle. And the next result that we have is the angle in the same segment of a circle are equal. So angle in the same segment means we are talking about, suppose we are talking about this chord AB, and this arc AB is corresponding to this chord AB, this arc, minor arc AB is there. We are talking about in this upper segment of the circle, we are having two angles corresponding to this chord AB. It is ACB, and second angle we have is ADB. We have to prove that any two angles that we draw corresponding to this chord AB, or you can say arc AB, these two angles, they are equal. So to prove this, what we are going to do is we are going to join this point A with the center O and this point B with the center O. Now if the measure of this angle C is x, we are given, what we know is that the measure of this angle at O will be 2x by our previous results, that the angle at the center of a circle is double the angle of the at any point on the circle subtended by an arc. Now if this angle is 2x, then this angle will be half of it. It is 2x by 2, that is equal to x. So what we get is both these angles, these are x and they are equal. And this is what we have to prove, that the angle in the same segment of a circle are equal. Now the second case we have is when the arc AB is the semicircle, then what we have is this angle is 180 degree and both these angles we know these will be of 90 degree. So they are equal. This is what we have to prove, that the angles in the semicircle we know they are 90 degrees, so that is why they are equal. Now the third case we have when it is the major arc, then what we are saying is that the reflex angles we are calculating over here, we are talking about this angle and this angle. So we can get this result just by writing the similar things as we have discussed in case A, with the condition that we are talking just about the reflex angle AOB, and most of the result we will get by subtracting the angle 360 minus angle AOB. We will get the corresponding results. Now in this question it is given that a line segment AB is there on this circle. This line segment we are talking about AB, and it subtends equal angle at two other points lying on the same side of the line segment. We are saying this is the point C, it is subtending some angle, and there is some point D and it is subtending some angle over here, and we have to prove that the point A, B, C, D, these are concyclic. Concyclic means they lie on a circle. Now suppose that these points that do not lie on the circle. So what we are going to do is we are considering 3 points over here. We are saying this is point A, B and C, and we have drawn a circle passing through these 3 points. We have considered that D does not lie on this circle, because if it will lie on the circle then the proof is complete. We are considering it is not lying on the circle. Then two cases may be there. Either the circle will intersect at this AD joint at the point D, or the second case is that this D is lying inside the circle. We have drawn this circle passing through the points A, B and C. We are saying D is not lying on the circle. Then we are saying if we extend this line AD, then this line will intersect this circle at some point D dash over here. So what we have now is, consider this ACB we are talking about, and second we are talking about is AD dash B. We are saying both these angles, if this angle is x, then this angle is x. Further, it was given to us that angle at A and C is x. Similarly, in the second figure, these two angles, these are given to be equal, and this angle and angle at D dash, they are equal because they are angles lying on the same segment. So what we get from this is, if we look at this triangle over here, we are talking about ADB and AD dash B, then this angle at X is the exterior angle to this angle D, and we know that the exterior angle of a triangle cannot be equal to the interior opposite angle. Similarly, in this we are talking about ADB is a triangle. We have extended this side. This is the exterior angle, this is the interior angle. This angle X is there. We are talking about this. We are talking about the triangle D dash B. For this is the exterior angle and this is the interior opposite angle. Again, these two cannot be equal. So we are saying that the supposition that D does not lie on this circle, it is wrong. So it must lie on this circle, that is D and D dash, these 2 points, these are the these 2 points, they coincide with each other, so they are same. In this next question, we have to find the value of x in the given figure. Some angles are given to us and we have to find the angles where x is marked. So in the first figure, we are having this angle is 30 degree. So this BC we are talking about, and the angle this BAC and BDC, both of these they lie on the same arc BC. So both these angles should be equal. So we are saying if this is 30 degree, then this angle is 30 degree. Now look at this triangle over here, BDC. So in this triangle we are saying we have to calculate the value of this x. So it should be 180 degree, sum of these all angles, that is 70 plus 30 plus x. So the answer, the value of x you will get, it is 80 degrees. It is the value of x. In the second figure, we are saying this angle is 35 degrees and this AB is the diameter. And we know that the angle in the semicircle, it is 90 degrees on this chord, on this arc. So this angle at P, this is 90 degree because it is the angle in the semicircle. Now we have the value of this angle P is 90 degree. So we can calculate the value of this angle A now. The value of this angle A will be 90 minus 35 degrees, that is equal to 55 degrees. Now look at these two angles over here. One angle we are talking about, it is PAB, and second angle we are talking about PQB. Both these angles they lie on the arc PB over here. This is the arc PB. So what we get is that both these angles should be equal. So the value of x we get in this case, it is 55 degrees. Now in this next question, we are having this circle is given to us and we are saying the radius of this circle is r, then this length OB is r, and this OA is r and OC is r. Now if we look at this triangle over here, we are talking about OAB. In this triangle, both these sides, these are r, this is r, this is r. So both these angles, if this angle is 25 degree, then this angle is also 25 degrees. Similarly, this angle and this angle should be 35 degrees because the side OA and OB, they are equal. So these angles at A and B should be equal. So we get that this total angle at A, that is 25 degree plus 35 degree, that is equal to 60 degree. So the angle at O will be 2 times this angle. If this angle is 60 degree, we are saying this value of this angle x will be 2 times 60, that is equal to 120 degrees. Now in this next question, we have to calculate the value of x. This angle is 90 degrees. This is given to be 90 degree. This angle is 120 degree. So this angle will be 360 minus 120 degree minus 90 degree, and the answer is 150 degree. Now if we look at these two angles over here, one is this angle BAC and second we are talking about BOC. So what we have is this angle at x, this is half of this angle, that is 150 by 2, that is equal to 75 degrees. This is half of this angle. So we get that the value of x is 75 degrees. Now in this next question, this angle is 130 degree. So this angle will be 360 minus 130, that is equal to 230 degree. Similarly, this angle x, this will be 230 by 2, that is equal to 115 degree. Why? Because this angle x and this angle AOC, they both are on this arc AC. This is the angle at the center and this is the angle on the circle, so the angle on the circle will be half the angle at the center. Similarly, in the next question, if this angle is 50 degree, we are talking about this CAB angle is 50 degree. This lies on this side over here, CDB. This angle will also be equal to 50 degree because both these angles, they lie on the same arc. Now next we have is these two lengths. We are saying OD is the radius, OB is the radius. So these two angles, value of x should be 50 degree because this is an, over here both these, the length of OD and OB, they are equal, and OBD triangle, when we look at these angles should be equal, so the value of x we will get it is 50 degrees. Now in this question we are given that this angle at this point D is 90 degrees and this point is the center of the circle O. So if this is the center of the circle, we have this angle over here, it is 90 degrees. So the angle at B will be, this angle at B will be 40 degrees. And if this angle is again 90 degree, then the value of this will be, x will be 50 degrees. Similarly, in the next question, we are given this angle AOC is 130 degrees. This is 130 degrees is given to us. Now AOB, this is a straight line. It means this remaining angle over here, this will be 180 minus 130 is equal to 50 degrees. Now if we look at this angle over here, this angle is COB and this is on the arc CB, and this CDB is also on the arc CB, and these two angles we are talking about, this angle X and this angle 50 degree, we are saying they are on the same arc. This angle is at the center and this is on the circle, so this will be half of this angle, so it is 50 by 2, that is equal to 25 degrees. Now in the next question, we are having this angle at A is 40 degree and this angle at A, this is on the arc CB, and on CB we are having this angle at D also, so this angle is of 40 degrees. Now if we look at the triangle over here, that is DCB, we are looking at this triangle, this angle at D is 40, B is 80, then the value of the angle at this C, the value of this X, that will be 180 degree minus 80 degree minus 40 degree, so the value of X we will get, that will be equal to 60 degree. Now in this question we are given this circle and the angle at A is given to be 50 degree. Now we have this length OA and OC, both these are the radius, these are the radius R, so both these lengths are equal. So if this angle at A is 50 degree, then this angle at C will be 50 degree. Now this angle at C, if we look at, this is on this arc B, we are talking about BCA angle, this is on this particular arc, and on this AB we can draw the angle like this, so the value of this X is 50 degree. Now in the next question we are having this angle at B, it is 50 degrees. So when we look at this angle, it is CBA we are talking about, and this arc AC is there, this arc AC is there. Now on the same arc we are having this angle ADC. So this angle X and this angle 50 degree, they will be equal to each other. So the value of X we will get it is 50 degrees. Next, the angle at O is given as 40 degree and this is X. Now what we have is, this is OA is the radius, OB is the radius. So what we have is that the angle at B will also be equal to X degrees. Now if we look at the triangle ABO over here, we will have 40 degree plus X degree plus X degree, that is equal to 180 degree. So we have 40 degree plus 2x, that is equal to 180 degree. So the value of X you will get it is 70 degrees. Now in this next question, we are given AB is the diameter of the circle. This AB is the diameter of the circle COR, and radius OD is perpendicular to this, OD is perpendicular to AB. If C is any point on the arc DB, this is the arc DB we are talking about, and C is any point on it, we have to find the angle BAD and angle ACD. That is, we have to calculate this BAD and angle ACD. These two angles we have to calculate. Now, when we look at this triangle over here, we have OA is equal to this, OA is the radius and OD is the radius and OB is the radius. So both these angles, if the value of this angle is X, then the value of this angle is also X, because it is an isosceles triangle. So both these angles will be X. Now in this triangle we are talking about, it is OAD triangle we are talking about. In OAD triangle, we have X plus 90 degree equal to 180 degree. So the value of 2x is 90 degree. So the value of X is 45 degrees. This is the value of X. Similarly, the value of angle at B, if this angle is Y, then this angle is Y, and if we look at the triangle OBD, in this triangle we are saying we will have the sum of the angles is 90 degree plus Y, and sum of all these angles should be 180 degree. So we get that the value of Y is 45 degrees. Similarly, the angle ACD will also be equal to this angle ACD. This is also equal to 45 degrees, and these are the three angles that we have to calculate. Now in this question we have to prove that the sum of these angles at X, Y and Z, we are talking about these three angles, that is the sum of the angles X and Y, that is equal to the angle Z. So from this figure we see that this angle at C and this angle at D, both of these angles they lie on the arc AB. So both these angles will be equal. These two angles, angle 3 and angle 4, will be equal. Further, this angle at Z, that is at the center, this lies on the same arc AB. So what we have is that this angle Z, this is 2 times the angle 3, or you can write 2 times the angle 4, or what we can write is that this angle Z, that is equal to angle 3 plus angle 4, or you can write it is 2 times angle 3, or you can write it is 2 times angle 4, because angle 3 is equal to angle 4. Now if we look at this triangle over here, we are talking about ACF, this triangle. This angle is 3, this is 1, and this is the exterior angle over here. So what we get is angle 1 plus angle 3 is equal to angle Y. Now if we look at the triangle EAD, D over here. We are talking about this triangle. So we are having over here angle 1 plus angle x, that is equal to angle 4. So what we have is, I am writing these two equations, that is angle y is equal to angle 1 plus angle 3 and angle 1 plus angle x is equal to angle 4. So when we add these equations, we will get angle 1 plus angle x plus angle y, that is equal to angle 1 plus angle 3 plus angle 4. These angle 1 gets cancelled, so we are left with angle x plus angle y, that is equal to angle 3 plus angle 4 is angle z. And this is what we have to prove, that angle x plus angle y is equal to angle z. Next, in this question we are given that O is the center of the circle and we have to prove that this angle XOZ, this is 2 times the sum of the angle XZY and the angle YXZ. So to prove this, we have done the construction over here, and the construction is that we have joined O and Y. Now we are talking about the arc XY. This is the arc XY. This arc is subtending the angle XZY, and this is also subtending the angle XOY at the center. So what we get is, if the value of this angle is x, then the value of this angle is 2x. Similarly, if we look at this arc YZ over here, this arc YZ is subtending the angle YXZ on the circle. Suppose the value of this angle is y, then this arc is also subtending the angle YOZ at the center, and this angle is 2 times y. So what we get is that this total angle over here, this is 2 times x plus y, that is equal to the sum of these two angles, and this is what we have to prove. Now in this next question we are given a triangle ABC. This is a triangle ABC and O is given to be the circumcenter of this triangle. Circumcenter means that from this center and radius OA, if we draw the circle, it will touch A, B and C. Then we have drawn a perpendicular OD over here. This is the perpendicular drawn from O to the side BC. We have to prove that this angle BOD, that is equal to the angle A. So first of all, we are doing the construction. We have joined BO and OC. Now if we look at this angle over here, this arc we are talking about BC, this arc BC, it is subtending this angle at this point, it is BAC on the circle, and it is subtending this angle BOC at the center. So what we have is that the value of this angle is x, then the value of this total angle, it will be 2 times x. Now we consider these two triangles. One is BOD and second triangle we are considering, it is ODC. So we are saying this is the radius R on both sides. This side is the common side and this angle is 90 degree. So by RHS criteria, both these triangles, these are congruent to each other. So it means that these two angles, that is BOD and DOC, these two angles, these are equal to each other. Total angle is 2x. It means individually these angles, the value of these angles is x. So what we get is that this x and this x, these two are equal to each other. Now in this next question we are given a circle, and this is the circle that is given to us, and it is given that two arcs are there. One is the arc AB and second is the arc CD, and these two arcs, these are intersecting at 90 degrees. We have to prove that the sum of the arcs AC and BD plus AD and CB, sum of these two arcs are equal, and they form a semicircle. So to prove this, we are going to do the construction over here, and the construction is, if O is the center of this circle, then we are joining OA, C with O, B with O, and D with O. Further, we are joining C and B. This thing is shown in this figure. Now, look at this triangle over here. We are talking about the triangle CEB. This triangle we are talking about. Now, in this triangle, we are saying this angle is 90 degree. Suppose this angle is X and this angle is Y. Then the sum of X and Y, X plus Y, is equal to 90 degree, because sum of the angles of the triangle should be 180 degree. Now look at this angle over here, this X we are talking about. It is on the arc DB, and this is at the center, it is forming this angle. So value of this angle at O will be 2 times X. Similarly, if we look at this B, we are having, this is the angle formed at B. So we are talking about the arc AC. Now at AC, thus at center, the angle formed is AOC, and the value of this angle is 2 times Y. So what we get from this is, if we want to find the measure of arc AXC plus measure of the arc, we are talking about AXC, and measure of the arc DZB, arc we are talking about. If we want to find the measure of these two, it is 2x plus 2y. 2 we have taken common, and it is x plus y. The value of x plus y we have, it is 90 degrees. So the answer we will get, it is 180 degree. So this thing proves that sum of these two arcs, means we are talking about that these two arcs, sum of these two arcs, they form a semicircle because their measure is 180 degree. Similarly, we can prove that the measure of the arc AYD and the arc CWB, measure of both these, sum of measure of both these arcs is also 180 degree. Next, we are given a circle of radius root 2 centimeter. This is the center of the circle, and the radius of the circle is root 2 centimeters. It is divided into two segments by a chord of length 2 centimeter. This chord AB is of length 2 centimeter. This is the chord AB we are saying, its length is 2 centimeter. We have to prove that the angle subtended by the chord in major segment is 45 degree. It means we are talking about this angle, we have to prove it is 45 degrees. So if we look at this triangle AOB, so what we have is root 2 square plus root 2 square, that is equal to 4, and that is equal to 2 square. So this thing proves that this triangle is right angled triangle, and it is right angled at this point O. This triangle is right angled at O, and if this angle is 90 degree, this angle is 90 degree, so this angle will be half of this, so it will be 45 degrees. So we are talking about, this is the arc AB over here. We are saying if this angle is 90 degree, then this angle will be 45 degrees. Now in this next question, we are given two circles, and these two circles, they intersect at the points A and B, and we are saying AC and AD respectively are the, this AC and AD are the diameters of the circle. We have to prove that CBD, these 3 points, these are collinear. So first of all, we look at this angle CBA. We have joined these points A and B. This is the construction part, and we are talking about the angle ABC. Now AOC is the diameter. It means this is the angle in the semicircle. So this angle is 90 degrees. Similarly, if we look at the angle ABD, we are saying this angle is also 90 degree because AO dash D, this is also the diameter. So this is the same angle in the semicircle. So sum of these two angles will be 180 degree. So what we get is that CBD is a straight line, that is CBD are collinear points. Next we are given a circle that is drawn on an isosceles triangle. So ABC is an isosceles triangle that is given to us. Isosceles means we are saying that this side AB and AC, these are equal to each other, and a circle is drawn on this isosceles triangle means with AB as the diameter we are drawing a circle over here. Let it intersect this side at the point D. What we have to prove is that this D is the midpoint of BC. So to prove this, we have done the construction over here and we have joined A and D. Now what we have is, if this AB is the diameter, then this angle ADB will be 90 degree. This is angle in a semicircle. Why? Because AOB is the diameter over here. So this angle is also 90 degree because BDC is a straight line. It is the side of the triangle, so it is a straight line. So this angle is also 90 degrees. So if we look at these two triangles over here, one triangle we are talking about is ADB, and second we are talking about is ADC. These two triangles we are talking about. So these two angles over here, these are of 90 degree. These two sides are given to be equal because the triangle is isosceles, and this is the common side over here. So these two triangles, these are congruent to each other, and if these two triangles are congruent to each other, it means this BD, that is equal to DC, and this is what we have to prove, that this point D is the midpoint of the side BC. In this question we are given that AB is the diameter of the circle. This AB is the diameter of the circle, and the chord CD, this is the chord CD, and the radius OC, they are equal. So basically we are given this is R. If we have joined OD and CB, this is part of construction, this is also R, and this length is also R. Now we are saying if we produced AC and we produced BD, they meet at the point P, and we have to prove that this angle at P, this is a constant angle, that it is wherever this chord CD lies, the value of this angle P will be some constant value. So to prove this, we are first talking about this triangle over here OCD. This is an isosceles equilateral triangle. So all its angles, measure of all its angles will be 60 degree. The measure of all these angles over here, these will be 60 degree. Now the next thing we have is, if we are saying that this AOB is the diameter, then this angle ACB, this angle is right angle over here, this angle is 90 degree. These angles over here, these are 60 degree angles. These angles are 60 degree angles. Now look at these angles over here. We are talking about COD and we are talking about CBD. Both these, they lie on the arc CD. So we are saying this angle over here, this will be 60 by 2 is equal to 30 degrees. This angle at B will be 30 degrees. Now look at this triangle over here. We are talking about the triangle BPC. This triangle we are talking about. So in this triangle we are saying AC is produced in this way, AC is produced in this way, this PC is produced to PA. Then this angle over here we have seen, this is 90 degree. this angle we have now, it is 30 degrees. So this is the exterior angle and these are the interior opposite angle. So the value of this angle will be 90 degree minus 30 degree is equal to 60 degree, and this is a constant value, and this is what we have to prove, that angle APB is constant. Now in this next question we are given a triangle ABC which is right angled at A. This triangle is given to us and it is right angled at A. In both these cases we are talking about. At this point A, it is right angled. Then hypotenuse of this triangle is BC and O is the midpoint of BC. This point O is the midpoint of BC. Then we have to prove that the distance of this O from A, B and C, all these 3 points, it is equal. So to prove this we are going to do the construction over here, and the construction is that we have drawn a circle with center as O and radius OB. This OB is the radius, R we are saying. This R is the radius over here, and we have drawn the circle. Suppose if this circle passes through A, then our proof is complete. We are saying suppose this circle is not passing through the point A, then 2 cases arise. Either the point A lies inside this circle or A lies outside this circle. So in this case A is lying outside this circle in the first diagram, and we are saying that this point A dash is there where this BA, it is intersecting this circle, and this point A dash is there, this is outside the circle. This angle at A, it is given to be 90 degree, and we are saying that it lies outside the circle. Now when we look at this triangle, suppose the angles over here at B and C, this is X, and this angle at C, it is Y. We are saying this angle is X and this angle at C, it is Y. Then what we have is the sum of these 2 angles. We are saying the sum of these 2 angles X and Y, that is 90 degree. Sum of these 2 angles X and Y, it is 90 degrees. Why? Because this triangle we are talking about, ABC triangle, that is given to us, it is right angled triangle. This ABC that is given to us, it is right angled triangle. Now the angle at A dash is also 90 degree, because these 2 angles, these are the angles in semicircle. These are the angles in semicircle, so these 2 angles are also of measure 90 degree. Now this thing is not possible, because if we look at the line over here, I am talking about this line BA over here, and I am talking about the line BA over here, and we are drawing the perpendicular from this point C. One, we are saying we have BCA is the perpendicular. Second, we are saying CA dash is the perpendicular. Similarly, in the second case, it is CA is the perpendicular and CA dash is the perpendicular. And this is not possible because from a point, given point, we can only draw one perpendicular on a given line. So we are saying that our supposition that A and A dash are 2 different points, it is wrong. So A and A dash, they must coincide. That is, this point A, that must lie at this point A dash. So the circle will pass through these points, these 3 points A, B and C. And this proves that the distance of the point O from B, O from B, O from C and O from A, the distance of all these 3 points, they are equal, as these 3 points, they lie on a circle. Next we have to prove is that the angle in a segment smaller than a semicircle is greater than a right angle. So we are talking about a circle and we are talking about the segment, say this BAC segment we are talking about. This is smaller than the semicircle. We have to prove that the angle formed over here, that is BAC, this angle, this is less than the right angle, this is less than the 90 degree. So to prove this, we are doing the construction over here, that we have joined the point B with the center O and we have joined the point C with the center O. Now this BC, it is the smaller segment. It means this angle over here, this is greater than 180 degree, and both of these angles, we are saying BOC and BAC, these are for the arcs BDC, the larger arc, and this is the angle at the center, and this is the angle on the circle. So what we have is that the angle on the circle is half the angle of this, so we are saying that it is greater than 180 by 2, that is equal to 90 degree. So it means that the angle in a segment smaller than a semicircle is greater than a right angle. Now in this figure it is given that O is the center of the given circle, and two chords, one is AB and second is CD. These two chords are given to us and they are intersecting at the point E inside the circle. We have to prove that the angle AOC, this angle over here, this angle AOC plus angle BOD, this angle BOD is equal to 2 times the angle AEC. This angle is 2 times this particular, this is the angle over here at E. So to prove this, we have done the construction over here, and the construction is that we have joined these 2 points C and B, so we get this chord CB, and we know that the angle made by the arc AC at the center, we are talking about this particular arc. So I am talking about this angle, this arc AC we are talking about. This arc is making the angle at the center, and this arc is making this angle at this point B over here. So what we have is, if this angle is X, then this angle is 2 times X. Similarly, we have, if this angle over here it is Y, then this angle is 2 times Y. Why? Because we are talking about the arc BD, and for BD we are having DCB, and second we are having DBOD. So if this angle is Y, this angle is 2Y. Now if we look at the triangle ECB over here, and this AEB is there, then we are talking about this angle at E. We are talking about this angle at E over here, this angle. This is the exterior angle of the triangle ACECB. This is the exterior angle, and its value is sum of interior opposite angle, that is X plus Y. And this is what we have to prove. We are saying that angle AOC, that is 2X, plus angle BOD, that is 2Y, that is equal to 2 times X plus Y, and X plus Y is this angle AEC. Now in this figure we are given that AB is the diameter of the circle with center O. This O is the center of the circle, and AB is the diameter of the circle. If AC, we are talking about this AC and BD are perpendiculars on the line PQ, we are talking about this line PQ. We are saying these two are the perpendiculars on this line PQ, and BD, it meets the circle at the point E. This is the point E given to us. We have to prove that AC is equal to ED. We have to prove that these two lengths AC and ED, these two lengths are equal to each other. Now to prove this, we are joining the points A and E. We are joining these 2 points A and E, and now angle AEB is 90 degrees. We are talking about this angle over here. This angle AEB is 90 degrees, but BED being a straight line, we have this angle over here, this is 90 degree, and this angle over here, this is 90 degrees. So now we have this angle is 90, this angle at D is 90 because it is perpendicular, and this angle at C is 90 because AC is perpendicular on PQ. So if we have to calculate this angle over at A, this angle at A we are talking about, the value of this angle is 360 degree minus 90 plus 90 plus 90. So the value of this angle we get, it is also 90 degrees. So each angle of this quadrilateral is 90 degree, and this proves that AEDC is a rectangle. This thing proves that, this thing we are saying, these all angles, these four angles, these are 90 degree. This thing proves that AEACD is a rectangle, and if it is a rectangle, we get that this length AC, that is equal to ED. Next, in the given figure, it is given that AC is the diameter of the circle, and this point O is the center of this circle, and the chord BD, this chord we are talking about BD, this is perpendicular to this AC. This is given to us that this angle over here, it is 90 degree, intersecting each other at the point E. This is the point E over here. Find out the values of P, Q, R and X. So if we look at this arc over here AD, on this arc we are having this angle X degrees, and on the same arc we are having the angle at B. So this angle over here, this will be X by 2 degrees. So if we look at this triangle over here, we are talking about this triangle AEB. We are having this angle is 90 degree. So sum of these two angles at P and this B is 90. So what we get is that P degree plus X by 2 degrees, that is equal to 90 degrees. Similarly, if we look at this arc over here, this AC over here, this is also on the same arc AD, on which AOD is there. So the relation we get from this is that Q, angle Q, that is equal to X degree by 2. This is the second relation we are getting over here. From the first, we will get P degree is equal to 90 minus X by 2. Q is X by 2. And last, we have to find the value of R. Now, if we look at this arc over here, that we are talking about this angle ABC. So this is AOC is the diameter. It is passing through the center O. So this total angle over here, this is 90 degree. So what we get is R degree plus X by 2, that is equal to 90 degree. So this implies us R degree is equal to 90 degree minus X by 2. This is the value of R that we obtain. This is the value of Q that we obtain, and this is the value of P that we have obtained. Now next we are given this circle, and it is given that this AB is the diameter of the circle with center at O, and we are saying AC and BD produce meet. This AC is produced and this BD is produced, and they meet at the point E over here, and angle COD, it is 40 degree. This is given to us. We have to calculate the value of the angle CED. We have to calculate the value of this angle. So we are saying since ACE is a straight line, we are saying ACE is a straight line. We are having angle ACB. We are talking about this angle ACB, as AOB is the diameter. So we are having this angle over here. this is 90 degrees angle. This angle is 90-degree angle. So this angle is also of measure 90 degrees. Now at this, look at this arc CD. Now at this arc CD, we are saying this angle COD is 40 degree. So angle CBD, this angle CBD, this will be 40 by 2, that is equal to 20 degrees. So what we get from this is, this angle at B, it is 20 degree. This angle at C, it is 90 degree. So the angle at E will be 90 minus 20. Why? Because we are talking about this triangle CBE triangle we are talking about. In this triangle, sum of the angle should be 180. So we get that the answer is 70 degrees. In this question, it is given that I is the in center of triangle ABC. This is the point I over here. And AI when produced meet the circumcircle of the triangle ABC in D. This is the circumcircle that is given to us. In circle means this circle we are talking about, that is inside this triangle, and circumcircle is this circle we are talking about, that is passing through the vertices of this triangle. We are saying we have produced AI and it meets this circumcircle at the point D. If angle BAC, this angle at over here, this is 56 degrees, angle ACB is 64 degrees, we have to calculate the values of the angle DBC. This angle we have to calculate. Next we have to calculate IBC. IBC is this angle we have to calculate. Then angle ADB, this angle we have to calculate, and angle BID, this angle we have to calculate. Now to calculate these values, we have done the construction over here, and the construction is that we have joined the points B and I. Now if we look at the triangle BAC, we are talking about this triangle over here. This is the triangle BAC. We have the sum of all these three angles should be 180. Now what we have over here, this angle is 56 degrees, this angle is 64 degrees. So we get that this angle will be equal to, the sum of all these three should be 180. So this angle will be equal to 60 degrees. Now as I is the in center of this circle, so we have AD is the angle bisector of BAC. So this gives us that this angle over here, this is half of this angle, this is 28 degrees. And if we are talking about this angle, it is DAC. This is on the arc DC. So on the same arc we are having this angle, that is CBD. So we get that the value of this angle is 28 degrees, because both these angles they are equal to each other. Now what we have to calculate is, first is we have to calculate the value of the angle DBC. So we have obtained the value as 28 degrees. Next we have to calculate the value of angle IBC. So we are talking about this angle over here, IBC. Now this angle we are saying this will be the half of the angle that is formed CBA. It is half of this angle. So this angle is 60 degree. So half of this angle will be 30 degree. So both these angles will be of 30 degree measure, because again BI is the angle bisector of ABC. Next we have to calculate the angle ADB. We are talking about this angle ADB. And the measure of this angle, this is on the arc AB, and if we look at the angle ACB, this is also on the same arc. So what we get is, the measure of this angle we have, it is 64 degree. So measure of this angle is also 64 degrees, because these two angles, these are in the same segment. Now in triangle BDI we are talking about. This is the triangle BDI. This is the triangle we are saying. In this triangle, we have the measure of the angle at D is 64 degree. The measure of this angle at B, this is 30 degree. The measure of this angle, it is 28 degree. So sum of both these angles will be 58 degree. Now what we have to calculate is we have to measure the angle at I. So that will be 180 degree minus 58 degree minus 28 degree. So the answer that we will get, it is not 28, it is 64. It is not 28, it is 64 degree. So the final answer that we will get after solving this, it is 58 degrees. So measure of this angle at I, it is 58 degrees.